Good evening, and welcome to Dreamy Science. Tonight we embark on a journey not through distant stars, but into the very fabric of what we perceive as nothingness. As we begin, I'd love to know where you're watching from, your city, your country, perhaps even what the night sky looks like outside your window. If you enjoy these peaceful explorations of science, please take a moment to like the video and subscribe. It truly helps this little corner of quiet curiosity grow. To those already subscribed, thank you sincerely for being part of this slow and thoughtful adventure. There's a beautiful paradox at the heart of our understanding of the universe, one that whispers of hidden depths in the most unassuming places. We often imagine space as an empty canvas, a silent void through which planets drift and stars burn. We picture the vacuum as a perfect nothingness, a pristine absence. Yet, the deeper we look, the more we understand that this perceived emptiness is anything but. It is a vibrant, seething sea of potential, a restless ocean of forces and particles flickering into and out of existence, even in the darkest, coldest reaches between galaxies. Right now, as you listen, the space around you, the air, the walls, the very atoms composing your body, is not truly solid. It is mostly vast, silent emptiness, punctuated by minuscule points of incredible density, bound by forces that stretch across distances imperceptible to our senses. The space between the nucleus and the electrons in an atom is proportionally vaster than the distance between the Sun and the planets in our solar system. And even this empty atomic space is not vacant. It is permeated by fields, by probabilities, by the hum of quantum activity. This realization that what we call empty is profoundly full, and what we call solid is largely void, carries a deep, quiet wonder. It changes how we perceive the world, revealing an intricate, active reality beneath the surface of the obvious. It invites us to look closer, to listen to the whispers of the universe, and to appreciate the profound beauty in its hidden mechanisms. This is why this subject rewards patient contemplation, making it perfect for these quiet hours we share. Have you ever truly considered what empty means? We use the word so readily, describing an empty glass, an empty room, or the vast empty expanse of space. Our intuition tells us that emptiness is the absence of anything at all, a perfect, silent void. Yet, if we allow our minds to drift beyond the immediate, beyond what our senses reveal, we discover that the universe has a far more profound and beautiful definition of emptiness. It is a definition that transforms the quiet void into a vibrant, active participant in the cosmic story, a stage upon which all existence plays out, but also, in a deeper sense, a player in the drama itself. Let us begin by carefully unpacking this most fundamental of concepts, peeling back the layers of our assumptions about what it means for something to simply not be there. When we try to imagine perfect emptiness, our minds often conjure images of a vacuum chamber, a space from which all air has been painstakingly removed. We think of the cold, dark silence between the stars, where no sound can travel, where even light itself seems to struggle against the vast distances. This is a good start, a tangible step toward understanding. But even in the most perfect vacuum we can create on Earth, or in the deepest cosmic void, a true, absolute nothingness remains elusive. At the very heart of modern physics, in the shimmering realm of quantum mechanics, we learn that the vacuum is not inert. It is not a passive backdrop. Instead, it is a seething, effervescent sea of activity, a field of pure potential. Picture, if you will, the surface of a perfectly still ocean. From a distance, it appears calm, uniform. But as you draw closer, you begin to see subtle ripples, tiny waves that rise and fall, seemingly from nowhere, only to vanish back into the placid surface. The quantum vacuum is much like this, but at scales far, far smaller than water molecules. Scientists call this phenomenon quantum fluctuations. These are fleeting, ephemeral particles and antiparticles, often referred to as virtual particles, that spontaneously pop into existence from the vacuum itself, exist for an unimaginably brief moment, and then annihilate each other, returning their energy back to the vacuum. This isn't science fiction, it's a fundamental prediction of quantum field theory, confirmed by subtle, persistent observations. These virtual particles are born from pure energy, borrowing just enough from the universe to manifest, and then repaying their energetic debt before any direct observation can trap them. It's like a cosmic loan system, where energy is borrowed and returned so quickly that the universe's books remain perfectly balanced. This constant invisible dance means that even in the deepest, most pristine vacuum, there is an inherent, restless energy, a quiet hum of creation and annihilation happening billions of times every second. The universe, it seems, abhors a true, absolute vacuum. This restless, energetic vacuum isn't just a theoretical curiosity. It has measurable effects. One of the most elegant demonstrations of the vacuum's non-empty nature is known as the Casimir effect. Imagine two perfectly flat, uncharged metal plates placed incredibly close to each other in a vacuum, separated by only a few nanometers, a distance so small that it's less than the width of a human hair. According to classical physics, these plates should simply sit there, feeling no force at all. But what scientists observe is astonishing. The plates are actually pushed together by a tiny but undeniable force. Why? Because the quantum vacuum, with its constant flickering of virtual particles, behaves differently in the tiny gap between the plates compared to the space outside. Only virtual particles with wavelengths small enough to fit between the plates can exist in that confined space. Outside the plates, however, virtual particles of all wavelengths are free to emerge. This creates an imbalance. More virtual particles exert pressure from the outside, pushing the plates inward, than can arise within the constrained space between them. It's as if the plates are being gently squeezed by the very fabric of the vacuum itself. This elegant experiment beautifully illustrates that even empty space possesses a subtle, intrinsic pressure, a tangible testament to its hidden activity. Now let's bring this concept closer to home, to the very matter that makes up you and everything around you. When you touch a table, it feels solid. When you stand on the ground, it feels firm. Yet, if we were to zoom in, past the surface of your skin, through the cells, and into the atoms themselves, we would find a startling amount of emptiness. An atom, for all its solidity, is overwhelmingly void. The nucleus, containing protons and neutrons, is incredibly dense, accounting for over 99.9% of the atom's mass. But it occupies only a minuscule fraction of the atom's total volume, about 1 part in a quadrillion. To put this into perspective, if the nucleus of an atom were the size of a blueberry, the electrons would be orbiting many miles away, and the atom itself would be the size of a sports stadium. Everything in between is what we perceive as empty space. But, as we've just explored, this isn't a true void. It's an arena of electromagnetic forces, of probabilities, of the quantum fields that define where an electron is likely to be found. The solidity we perceive in matter isn't due to atoms being tightly packed, but rather to the powerful electromagnetic repulsion between the electron clouds of adjacent atoms. It's the force fields, not solid little balls, that prevent your hand from passing through a table. The universe, at its most fundamental level, is a dance of forces across vast internal emptiness, an intricate ballet orchestrated by the quantum vacuum itself. This understanding of the quote "for" profoundly reshapes our perception of reality. It tells us that the universe is not made of inert building blocks, floating in a passive emptiness, but rather of dynamic patterns of energy and probability arising from a restless, vibrating backdrop. What we perceive as solid matter is more akin to a complex, stable wave pattern on a deeply active ocean, an island of order sustained by underlying constant flux. This principle extends beyond the subatomic. The very forces that bind atoms together, that give molecules their shape, that allow life to emerge from chemistry, all are manifestations of these fundamental fields and their interactions within this non-empty vacuum. It means that the space between stars, the space between atoms, and even the space within your own cells is not a barren nothingness, but a lively, energetic medium. It is the stage, the conductor, and even a subtle player in the cosmic symphony. There's a particular comfort in understanding this. It means we are not adrift in a cold, indifferent void, but are intimately connected to a universe that is ceaselessly active, even in its most seemingly empty reaches. It invites a humility, a quiet awe, as we realize that our everyday experience of solidity and emptiness is merely a surface phenomenon, a useful illusion created by deeper, more intricate truths. The universe, it seems, is far more alive, far more interconnected, and far more subtle than our initial perceptions might suggest. So we've begun to unmask the hidden nature of emptiness, revealing it as a vibrant, energetic medium, a quantum ocean that hums with activity and subtly shapes the very structure of matter. This realization, that space is not a passive container, but an active participant, is a foundational shift in perspective. But if the void itself is so profoundly dynamic, what does this imply for the vast cosmic structures embedded within it? What happens when this active emptiness stretches across billions of light years, and how does it influence the grand architecture of galaxies and clusters? How does this subtle, ever-present energy of the vacuum manifest on the larger scales, shaping the universe in ways we are only beginning to comprehend? That question leads us to consider the universe not just as a collection of objects, but as a vast interconnected tapestry where space itself plays a crucial, perhaps even surprising, role. We left off peering into the heart of what we once called emptiness, discovering a universe far more vibrant and alive than we ever dared imagine. We saw the quantum vacuum not as a passive void, but as a seething, effervescent sea of potential, where virtual particles flicker into existence and vanish, borrowing and repaying energy in a cosmic dance. We understood that even the solidity of matter is an illusion, a complex, stable wave pattern on a deeply active ocean, held together by forces rather than tightly packed particles. But the whispers of the void don't stop at the atomic scale. They echo across the vastness, shaping galaxies, influencing clusters, and orchestrating the very destiny of the cosmos. How does this subtle, ever-present energy, this restless hum of the quantum realm manifest on the largest scales? How does the microscopic ballet of virtual particles translate into the grand cosmic waltz? This is where our journey truly begins to stretch the imagination, where the emptiness we inhabit reveals its most profound and unexpected secret. Imagine, if you will, that the fabric of space itself isn't merely a stage upon which the cosmic drama unfolds, but an active participant, a character with its own inherent energy and will. For decades, our understanding of the universe revolved around gravity, the grand sculptor that pulls matter together, forming stars, planets, and galaxies. We pictured an expanding universe, yes, but one where gravity would eventually slow that expansion, perhaps even reverse it, leading to a quote 6. It was a neat, elegant picture, a cosmic pendulum swinging back and forth. But then, the universe began to whisper a different story. In the late 1990s, astronomers, observing distant supernovae, cosmic beacons that allow us to measure the universe's expansion rate, made a truly astonishing discovery. They expected to see the expansion slowing down. Instead, they found it was speeding up. The universe wasn't just expanding, it was accelerating its expansion, as if some unseen hand were constantly pushing it outwards, faster and faster, defying the gravitational pull of all the matter within it. This was a profound shock, a cosmic curveball that sent physicists scrambling for answers. What force could possibly be strong enough, pervasive enough, to overcome the combined gravitational might of countless galaxies? The answer, or at least our current best explanation, is something we call dark energy. Now, don't let the name intimidate you. Dark simply means we can't directly observe it with light or other electromagnetic radiation, much like, quote, refers to matter we can't see, and energy refers to its effect. Think of dark energy not as a substance, but as an intrinsic property of space itself. It's as if every cubic inch of seemingly empty space comes pre-packaged with a tiny inherent amount of energy, and that energy exerts a repulsive pressure, pushing space apart. This isn't just an abstract concept. It's the cosmic manifestation of the quantum vacuum's restless activity we discussed earlier. Remember those virtual particles constantly popping in and out of existence? They contribute to the vacuum's energy. If space itself is generating these fluctuations, then space itself possesses energy. And if that energy has a negative pressure, meaning it pushes outwards rather than pulling inwards, then it becomes the perfect candidate for dark energy. It's the universe's very own built-in anti-gravity mechanism. Consider this. As the universe expands, more space is created. And because dark energy is an inherent property of space, as more space is created, more dark energy comes into existence. It's a self-perpetuating cycle. More space means more dark energy, which means a stronger push, which means even more space is created, and so on. It's why the expansion isn't just happening, it's accelerating. It's like baking bread dough. As the dough rises, the raisins within it move further apart. But imagine if the dough itself, as it expanded, also somehow gained more leavening agent, causing it to rise even faster over time. That's the accelerating universe driven by dark energy. This pervasive, invisible force now dominates the cosmic landscape. Current estimates suggest that dark energy accounts for roughly 68% of the total energy density of the universe. Compare that to the 27% of dark matter and a mere 5% of ordinary matter, the stars, planets, and everything we can see and touch. We, the visible universe, are but a tiny shimmering speck in a cosmos overwhelmingly shaped by forces we cannot see and barely understand. And this brings us to the profound, slightly unsettling implication that gives our journey its name. Quote, 10. What does it mean to be inside a cosmic whole? It means our universe isn't just expanding, it's being actively stretched, diluted, and pulled apart by this intrinsic energy of space. Imagine standing on a giant, infinitely stretching rubber sheet. Everything around you is moving away, not because it's physically running, but because the sheet itself is expanding between you and it. Now, imagine that stretching is accelerating. Galaxies that were once visible to us are receding faster and faster. Eventually, they will cross a cosmic horizon, a point beyond which their light will never reach us. No matter how long we wait, they will simply vanish from our observable universe, not because they're gone, but because the space between us and them expands too rapidly for their light to ever bridge the gap. This accelerating expansion creates a sort of cosmic isolation. Our observable universe, the sphere of all we can ever hope to see, is effectively shrinking in terms of the number of galaxies it contains. Over trillions of years, if this acceleration continues, our local group of galaxies, the Milky Way, Andromeda, and a few smaller companions, will be all that remains visible to us. The rest of the universe will have receded beyond our observational reach, swallowed by the ever-expanding cosmic quote, 11, that is space itself. This isn't a physical hole in the traditional sense, a void with defined edges. Instead, it's a conceptual hole, a profound and accelerating separation. It's the universe expanding itself into an ever greater expanse, pushing everything away from everything else. We are not just in a hole. In a very real sense, the accelerating expansion is the hole, and we are constantly falling deeper into its expanding interior, losing sight of the edges as they recede faster than light. Think about the implications of this. Our very existence, our cosmic address, is within a region of space that is constantly being created, constantly pushing outwards. The ground beneath our cosmic feet is not static. It is a dynamic, effervescent engine of expansion. The quote 12 isn't a blank canvas. It's the active artist sketching out an ever larger, increasingly isolated cosmic masterpiece. This leads us to one of the most perplexing and fascinating mysteries in modern physics, the cosmological constant problem. If dark energy is indeed the energy of the quantum vacuum, then theoretical calculations of this vacuum energy yield an incredibly, astronomically large number. We're talking about a value that is something like 10 to the 100 times larger than the observed value of dark energy. This discrepancy, a factor of 1 followed by 120 zeros, is arguably the largest mismatch between theory and observation in all of science. It's an embarrassment of riches, a cosmic puzzle of epic proportions. Why is the vacuum energy we observe so incredibly small compared to what our theories predict? Why does space have just the right amount of repulsive energy to drive the universe's acceleration, but not so much that it would have torn the cosmos apart in its infancy? It's a fine-tuning problem on a grand scale, suggesting either a profound misunderstanding of quantum gravity or perhaps a deeper, more subtle mechanism at play. Some theories propose that exotic quantum fields or extra dimensions might be involved, dampening the vacuum energy to its observed value. Others suggest that our universe might be just one patch in a vast multiverse, with different regions having different values of vacuum energy, and we simply happen to live in one that allows for stars, galaxies, and life to form. Regardless of the ultimate answer, the existence of dark energy fundamentally redefines our cosmic home. We are not in a static, predictable universe. We are in a dynamic, evolving, accelerating expanse where the very fabric of space is an energetic entity, driving a relentless expansion that will ultimately isolate us from the vast majority of our cosmic neighbours. Nobody explicitly told us this when we learned about stars and planets. It was a discovery, a revelation that came much later, changing everything. So when we look up at the night sky, we are not just gazing at distant suns. We are looking through a medium that is actively expanding, carrying those suns away from us at ever-increasing speeds. We are observing the dance of gravity, yes, but also the relentless push of dark energy, the cosmic echo of the quantum vacuum's restless hum. The universe is not just expanding, it is being actively stretched, thinner and thinner, by a force originating from what we once believed was nothing. This perspective invites a profound shift in how we perceive our place. We are not passive observers in a fixed arena. We are participants in a cosmic drama where the stage itself is alive, growing, and constantly reshaping the performance. The universe isn't just out there, it's also in here, woven into the very fabric of our local space, influencing every moment of our cosmic journey. What does it mean, then, for consciousness, for life, to emerge within such a dynamic, accelerating, and ultimately isolating cosmic environment? It means that our existence is even more precious, our observations even more urgent, for the window to the grand cosmic tapestry is slowly, inexorably closing. The light from distant galaxies carries stories of the past, but the accelerating expansion warns us that those stories will eventually be beyond our reach. As we continue to explore this profound cosmic truth, we are invited to look closer, to listen more intently to the whispers of the void. We are not just inside a cosmic hole, we are living within its active, energetic expansion. And understanding this phenomenon, this pervasive force, is not just a scientific endeavour, it's a philosophical awakening, a re-evaluation of our most fundamental assumptions about reality. In our next chapter, we will delve even deeper into the implications of this cosmic dynamism. We will explore how this inherent energy of space might not only be pushing things apart, but also subtly influencing the very nature of gravity itself, and perhaps even hinting at the universe's ultimate fate within this ever-expanding, accelerating whole. Get ready, because the revelations only become more astonishing. We left off with a profound puzzle, didn't we? The cosmological constant problem. That vast, almost unimaginable discrepancy between our theoretical calculations of vacuum energy and the observed, relatively paltry sum that actually drives the universe's acceleration. It's a cosmic whisper that tells us we are missing something fundamental, a crucial piece of the grand design. But even with this gap in our understanding, the undeniable presence of dark energy continues its relentless work, reshaping the very fabric of existence. So what does this unseen force truly do? How does it interact with the universe we know, the universe woven from matter and light, bound by the familiar embrace of gravity. Imagine gravity, that ancient pervasive force, as the universe's great unifier. It pulls planets into orbit around stars, gathers stars into galaxies, and clusters galaxies into vast cosmic filaments. It's the sculptor of structure, the binder of worlds, always working to draw things closer, to condense and compact. Gravity, in its essence, is attraction, a cosmic magnetism. But dark energy is gravity's antithesis. It's not just a passive resistance, it's an active, repulsive pressure, an inherent property of space itself that pushes outward. Think of it as an _13_ force, though perhaps that term is too simplistic, too rooted in our everyday experience. It's not a force that cancels gravity, it's a force that overwhelms it on the largest scales, like a gentle, persistent breeze that can eventually move mountains if given enough time and expanse. We don't feel dark energy in our daily lives. It doesn't lift our feet off the ground or send objects flying into the sky. Its influence is far too diffuse, too subtle for our local gravitational binds. Here, on Earth, within our solar system, even within our Milky Way galaxy, gravity reigns supreme. The gravitational pull of our Sun keeps Earth in its orbit, and the combined gravity of billions of stars holds our galaxy together. Dark energy's effect on these local structures is negligible, drowned out by the sheer mass and proximity of matter. But step back, zoom out, beyond the boundaries of galaxies, beyond clusters of galaxies, to the vast, truly empty stretches of intergalactic space. Here, where matter is sparse and gravity's grip is weak, dark energy comes into its own. It's here that its subtle, outward push accumulates, dominating the cosmic landscape. It's like observing two individuals in a tug-of-war. Up close, the strength of their arms is all that matters, but step back to watch two entire armies engaged in the same game, and suddenly the wind, once a minor nuisance, becomes a decisive factor, pushing one side back with an inexorable, cumulative force. This cosmic tug-of-war between gravity's embrace and dark energy's push is the defining drama of our universe. For billions of years, gravity held sway, allowing galaxies to form and cluster, drawing matter together into the intricate cosmic web we observe. But in the last few billion years, dark energy has gained the upper hand. Its relentless uniform pressure spread throughout all of space has begun to win. It is actively pulling apart the fabric of the cosmos, not by ripping, but by stretching, by ever so gently but firmly increasing the distances between everything not gravitationally bound. It's the force that inflates our cosmic whole, pushing the edges of our observable universe further and further away, faster and faster. What does this relentless expansion, this cosmic push, mean for the grand narrative of our universe? What chapter follows the one we are living now, the one where we find ourselves within this accelerating cosmic whole? The universe, like all stories, has an ending. And dark energy, that unseen architect, is busy writing the final chapters. For decades, cosmologists have pondered the ultimate fate of the universe, offering several compelling, albeit often sobering, possibilities. The most widely accepted scenario, the one our current observations strongly lean towards, is often called the Big Freeze, or sometimes the heat death of the universe. Imagine a vast empty canvas slowly fading to black. In this future, dark energy continues its dominance, driving the universe to expand forever at an ever-increasing rate. As space stretches, everything within it cools. Galaxies, once vibrant islands of stars, will drift further and further apart, receding beyond each other's cosmic horizons until they are utterly alone, isolated in an ocean of ever-expanding void. Within these lonely galaxies, stars will continue their life cycles, burning through their fuel, eventually winking out into cold, dark stellar remnants, white dwarfs, neutron stars, and black holes. New stars will cease to form as the gas and dust needed for their birth become too diffuse, too spread out across the expanding cosmos. The universe will grow darker, colder, emptier. Even black holes, those cosmic behemoths, are not immortal. Over unimaginably vast timescales, they are predicted to slowly evaporate through a process called Hawking radiation, releasing their energy in a final faint glow. What will remain, billions upon billions of years from now, is a universe of scattered photons, neutrinos, electrons and positrons, drifting endlessly through an infinite, frigid expanse. All structure, all warmth, all activity will have ceased. The universe will have reached a state of maximum entropy, a perfect, unchanging and utterly cold equilibrium. It's a fate of ultimate, profound stillness, a cosmic exhalation. Then there's a more dramatic, almost apocalyptic possibility, though less likely given what we currently observe, the Big Rip. What if dark energy isn't just constant, but actually grows stronger over time, its repulsive pressure intensifying? In this scenario, the accelerating expansion would become so powerful, so overwhelming, that it would eventually overcome all forces. First, gravitationally bound structures like galaxy clusters would be torn apart. Then, individual galaxies would disintegrate, their stars flung into the void. Eventually, even stars, planets, and finally atoms themselves would be ripped asunder, their fundamental particles isolated from each other, unable to maintain any form of structure. It's a universe literally shredded into its most basic components, a cosmic unravelling of unimaginable violence, leaving behind nothing but a soup of isolated elementary particles, forever separated by an infinitely expanding space. A truly terrifying thought, but thankfully current data does not support such an extreme outcome. And what of the Big Crunch? The romantic notion of a universe collapsing back into itself, perhaps to be reborn in a new Big Bang. While a captivating thought, a cyclical universe of expansion and contraction, our accelerating expansion suggests this is not our cosmic destiny. The dominance of dark energy, that relentless outward push, has effectively sealed the universe's fate against such a dramatic reversal. The gravitational attraction of all matter, even including the mysterious dark matter, simply isn't enough to overcome dark energy's expansive will. These fates are not just distant theoretical musings. They are the direct consequence of the cosmic whole we discussed, the accelerating expansion that is already isolating us. As galaxies recede faster and faster, they will eventually cross an event horizon, much like the one around a black hole but in reverse. The light from these distant beacons will stretch and fade, redshifted into oblivion, until they are, quite simply, gone from our view. Future civilizations billions of years from now might gaze out into the night sky and see only a handful of nearby galaxies, our own local group, with the rest of the cosmos forever hidden from their sight, having expanded beyond the reach of any observable light signal. Our current window into the vastness of the universe, this spectacular panorama of billions of galaxies, is a fleeting, precious gift. What does it mean to live in a universe with such a profound yet largely unseen destiny? Does it diminish our existence, or does it imbue it with an even greater, more poignant significance? Perhaps it is precisely this transient, accelerating nature that makes our brief moment of observation, our shared quest for understanding, so incredibly precious. To gaze out at the cosmos, knowing that much of what we see today will one day be forever beyond our reach, is to witness a profound, melancholic beauty. It compels us to look closer, to cherish every photon, every whisper from the distant past, for they are glimpses of a universe that is actively, irrevocably changing. We are living in a unique era, a cosmic sweet spot where the universe is old enough for complex structures like galaxies and stars to have formed, but young enough for us to still witness the vast tapestry of the cosmos before it recedes into eternal isolation. It is a moment of profound revelation, a time to truly appreciate the incredible, dynamic nature of our reality. But even in this grand unfolding drama of cosmic expansion and ultimate fate, the universe holds more secrets, more layers of reality waiting to be unmasked. We've explored the quota-60 void and the accelerating expanse. Next, we will turn our gaze inward, not to the vastness of space, but to the very fabric of our being, to the atoms and the quantum realm that give rise to our perceived solidity, and ask, is there another kind of 17 hidden within us, within everything we touch and see, a deeper emptiness that paradoxically gives rise to all that is? Chapter 4. We've spoken of the vast cosmic whole, the accelerating expansion of our universe, driven by the mysterious dark energy that stretches the very fabric of space. We've contemplated the chilling prospect of a big freeze, where galaxies recede into an eternal night, leaving us adrift in an ever-emptying void. But what if I told you that the concept of a 18 isn't just out there, in the unfathomable distances between galaxies, but right here? What if the very matter we touch, the ground beneath our feet, the hands you hold before you, are themselves intricate, shimmering patterns of a profound emptiness? It's time to look closer, to delve into the other kind of whole I promised, one that resides within matter itself. This isn't a cosmic phenomenon, but a quantum revelation, a truth so fundamental it reshapes our understanding of solidity, of presence, of everything we perceive as real. Consider for a moment the most solid thing you can imagine, perhaps a granite countertop, unyielding and firm, or the sturdy trunk of an ancient oak, rooted deep in the earth. You touch it, you feel its resistance, its density, its undeniable thingness. It feels utterly substantial, a definitive barrier against the nothingness. But what if this feeling, this perception of solidity, is one of the universe's most exquisite illusions? Science, with its patient and relentless curiosity, has peered into the heart of matter, dismantling it layer by layer, seeking its ultimate components, and what it has found is astonishing. When we zoom in past the visible surface, past the cellular structures, past the molecular bonds, we arrive at the atom, and here the illusion truly begins to unravel. Imagine an atom, not as the dense, impenetrable sphere we might have drawn in a school textbook, but as a miniature solar system. At its centre, a tiny, incredibly dense nucleus, composed of protons and neutrons. And orbiting this nucleus, at vast distances relative to their size, are electrons. Now here's where the quote 20 truly manifests. If the nucleus of an atom were the size of a marble, the nearest electron would be orbiting it at a distance equivalent to several miles away. Think about that for a moment. Miles of nothing between the nucleus and its electrons. This means that an atom, the fundamental building block of everything around us, is almost entirely empty space. Over 99.99999% of its volume is, in fact, void. Your granite countertop, that ancient oak, your very body. They are colossal arrangements of these mostly empty structures, held together by invisible forces. So, if atoms are so empty, why don't we just fall through the floor? Why don't our hands pass through each other like ghosts? This is where the dance of forces comes into play, a testament to the universe's elegant engineering. The electrons, though tiny and distant, carry a negative electric charge. The protons in the nucleus carry a positive charge, and as we learned in our earlier science lessons, opposite charges attract, while like charges repel. When you try to push your hand through a table, it's not the solidity of the table's atoms that resists you. It's the electromagnetic repulsion between the electrons in your hand's atoms and the electrons in the table's atoms. They push back, creating the sensation of firmness of an impenetrable surface. It's a fundamental repulsion, a quantum boundary that prevents matter from simply collapsing into itself. This force, along with the Pauli exclusion principle, which essentially states that no two electrons can occupy the exact same quantum state at the same time and place, creates the resistance and structure we perceive as solidity. But let's go deeper still. The atomic model, with its nucleus and orbiting electrons, is still a simplification. To truly understand the quote 22 within matter, we must venture into the shimmering realm of quantum mechanics, where our everyday intuitions dissolve like mist. In the quantum world, electrons aren't tiny planets orbiting a sun. They are far stranger, far more elusive. They exist not as discrete particles in a definite location, but as probability clouds, as waves of potential spread out around the nucleus. We can only talk about the likelihood of finding an electron at a certain point in space. It's a continuous buzzing field of potential, not a set of tiny marbles. When an electron just quote 3 from one energy level to another, it doesn't traverse the space in between. It simply appears in the new state, as if the entire probability cloud shifts its configuration. This is the inherent mind-bending nature of quantum reality. And what about the nucleus itself? Those protons and neutrons, once thought to be fundamental, are themselves composed of even smaller entities called quarks, held together by the quote 24, mediated by particles called gluons. But here's the kicker. Even quarks and gluons aren't solid little beads. They are understood as excitations, as localized ripples or vibrations in quantum fields that permeate all of space. Imagine a vast, still ocean. A ripple, a wave, passes across its surface. That wave is the water, but it's not a fixed, solid thing. It's a dynamic pattern of energy moving through the medium. In a profoundly analogous way, what we call a quote 26, an electron, a quark, a photon, is not a tiny hard nugget of quote 27. It is an excitation, a localized bundle of energy, a vibration within an underlying quantum field that extends throughout the universe. So, when we say an atom is mostly empty space, That quote 28 isn't truly empty in the classical sense. It's the very same vibrant, seething quantum vacuum we discussed in Chapter 1, a field of potential, constantly fizzing with virtual particles appearing and disappearing. The quote 29 that make up the atom are simply specific stable patterns of energy within these ubiquitous fields. They are like complex stable wave patterns on a deeply active ocean. The quote 30 within matter, then, is not a barren void, but a dynamic, energetic field sculpted and patterned into the forms we perceive as solid. This perspective is truly transformative, isn't it? It means that everything we perceive as solid, as substantial, is fundamentally an intricate dance of forces and energy within a vast, mostly unmanifested field of potential. Your body, the chair you sit on, the air you breathe, all are manifestations of energy, coalesced into specific temporary patterns within the quantum vacuum. We are quite literally shimmering arrangements of energy in a field of dynamic emptiness. This profound truth echoes across scales. Just as the universe itself is expanding into a cosmic whole, driven by the energy of the quantum vacuum, so too is the matter within that universe fundamentally porous, a structured emptiness animated by quantum fields. The solidity we experience is a testament to the incredible power of these fundamental forces and the intricate patterns they weave. Think of the beauty in this. The universe doesn't present us with simple solid blocks. Instead, it offers a symphony of vibrations, a dance of forces, a constant emergence and disappearance of potential. It's not about finding the smallest, hardest, indivisible particle. It's about understanding the underlying fields, the fundamental vibrations, the dynamic emptiness that gives rise to everything. This understanding invites us to look beyond the surface, to listen to the whispers of the quantum realm, to appreciate the profound beauty in the fact that we are, in essence, intricate patterns of energy in a vast, mostly empty space. We are part of the cosmic whole, and the cosmic whole is, in a very real sense, part of us. We are not just in a cosmic whole. We are composed of tiny dynamic wholes, held together by invisible forces. This realization is not meant to diminish your sense of self or the reality of your experience. Quite the opposite. It is meant to elevate it, to infuse it with a sense of wonder, to reveal the deep interconnected tapestry of existence, to understand that your very being is a complex stable wave pattern on a deeply active ocean of quantum fields, is to understand the universe's most intimate secret. In our next exploration, we will weave together these threads, the cosmic whole of dark energy, the quantum whole within matter, and begin to contemplate what this means for our place within this astonishing, dynamic, and profoundly mysterious universe. We will ask, if reality is so fluid, so empty, so dependent on observation, what then is the nature of consciousness itself? And how does our awareness fit into this grand, shimmering cosmic dance? We've peeled back so many layers, haven't we? From the cosmic expansion driven by an invisible force to the vast emptiness within the very atoms that make us, we've found that reality is far more fluid, far more dynamic than any static, solid picture could ever convey. We've discovered that everything, at its most fundamental level, is a shimmering arrangement of energy, a complex, stable wave pattern on a deeply active ocean of potential. But what gives that potential its form? What causes these shimmering arrangements to coalesce into the world we perceive? The chair you're sitting on, the light illuminating your space, even the thoughts dancing in your mind. If particles aren't tiny, hard marbles, but rather excitations in a field, then how do they decide where to be, what to be? How does this vast, mostly unmanifested field of potential transform into the tangible reality we inhabit? This, my friends, brings us to one of the most profound and mind-bending mysteries at the heart of quantum mechanics: the role of the observer. Imagine, if you will, an electron. In the classical Newtonian world, an electron is a tiny particle with a definite position and a definite momentum, zipping around an atomic nucleus like a miniature planet. Simple, right? But the quantum world laughs at such simplistic notions. In that deeper realm, an electron doesn't exist as a single, fixed point until we look for it. Before observation, it exists in what we call a superposition of states. It's not here or there, it's simultaneously here and there and everywhere else it could possibly be, all at once. Think of it like this. Imagine a coin spinning in the air. Before it lands, before you slap your hand over it, is it heads or tails? It's neither, and it's both. It exists in a state of potential, a blur of possibilities. Only when it interacts with your hand, when it is, quote, 32, quote, in the sense of being forced into a definite state, does it, quote, 33, quote, into either heads or tails. This isn't just a quirky analogy for subatomic particles, it's a fundamental description of their reality. An electron left undisturbed is a wave of probability spread across space. It doesn't have a specific location. It has a potential for many locations, each with a certain probability. It's a whisper of possibility, a ghost of what could be. But the moment you try to measure its position, the moment it interacts with a photon from your measuring device, or even another particle in its environment, that wave of probability instantaneously, quote, 34. The electron is forced to choose one specific location out of all its potential positions, and suddenly it is here. It becomes a particle. This phenomenon, known as wave-particle duality, and the Yule collapse of the wave function, is not just an oddity, it's the very mechanism by which the universe seems to manifest itself from the quantum foam. It suggests that reality, as we experience it, isn't a pre-existing objective tapestry that we merely observe. Instead, it's something that emerges, something that solidifies through interaction. And this is where the quote 35 truly begins to twist our perceptions. What constitutes an quote 36? Is it merely a measurement by a scientific instrument, or is there something more profound at play? For a long time, scientists grappled with the idea that conscious observation might be necessary for this collapse. Does the universe require a mind to bring it into being? It's a tantalizing, almost mystical thought. But the prevailing scientific understanding suggests that quote 37 quote in quantum mechanics is a much broader concept. It refers to any interaction that causes a quantum system to become entangled with its environment, effectively quote 38 quote its quantum uncertainty into the classical world. Even a single photon bumping into an electron, or an electron interacting with a gas molecule, can be enough to cause this collapse. The environment itself acts as an quote 39 quote, constantly interacting with quantum systems and forcing them into definite states. So, while your conscious gaze isn't strictly necessary for an electron to pick a spot, the implication remains. Without any interaction, without any form of observation, reality remains a blurry, undefined potential. It's a universe of probabilities waiting to be actualized. Now pause for a moment and let that sink in. We've spoken about the vast emptiness of space, a vibrant quantum vacuum constantly fizzing with virtual particles. We've explored the emptiness within atoms, where solidity is an illusion created by forces, not by solid bits. And now we discover that even the very existence of those bits, those excitations in the quantum fields, is contingent upon interaction. The universe, then, is not merely empty in the sense of lacking matter, but empty in the sense of being a vast, shimmering canvas of unmanifested potential. It's a cosmic stage where the scenery and actors only truly appear when the light hits them, when they interact with something else. The Usser's quote 43 isn't just an outward expansion into a cold void. It's also the fundamental nature of reality itself, a profound, active and mostly unactualized potential, waiting for the dance of interaction to give it form. Consider the implications for our own existence. If our bodies are made of atoms, and those atoms are mostly space, and the particles within them are merely excitations in quantum fields that only solidify through interaction, then what are we? We are not solid, fixed entities moving through a solid, fixed world. We are complex, stable patterns of energy and information, constantly interacting with the quantum field, constantly participating in the ongoing act of manifestation. We are, in a very real sense, part of the process that brings the universe into being. This changes our perception of the quote 45 entirely. It's not just a physical void stretching between galaxies or the vast interior of an atom. It is the fundamental active potential from which all reality springs. And we, the observers, the interactors, are intimately intertwined with this process. We are not separate from the universe, looking in. We are woven into its very fabric, participating in its continuous creation. This profound interactivity also brings us back to that monumental puzzle we touched upon earlier, the cosmological constant problem. Remember, the observed value of dark energy, the energy inherent in space that's pushing the universe apart, is incredibly tiny compared to what our best quantum theories predict for the energy of the vacuum. A discrepancy of 10 to the power of 120, a number so vast it's almost meaningless. It's like expecting to find an ocean and instead finding a single drop of water and then wondering how that single drop can still be so powerful as to push the entire cosmos apart. Why is it so small? Why is the universe's intrinsic energy so finely tuned? If the quantum vacuum is indeed a seething ocean of virtual particles, constantly popping in and out of existence, then its energy density should be enormous. Yet, the universe we inhabit has a vacuum energy that is almost, but not quite, zero. It's perfectly balanced to allow for the formation of stars, galaxies, and eventually us. Could this fine-tuning be linked to the very process of manifestation we've been discussing? If reality emerges from potential through interaction, through observation, then perhaps the conditions for any observation to occur, for any complex structure to arise, require such a delicately balanced vacuum energy. If the vacuum energy were too high, the universe would have expanded so rapidly that matter could never have coalesced into stars and galaxies. If it were too low, the universe might have collapsed back on itself before anything interesting could happen. This line of thought leads some physicists to consider the anthropic principle, which suggests that the fundamental constants of the universe are precisely what they are, because if they were any different, we wouldn't be here to observe them. It's a controversial idea, sometimes seen as circular reasoning, but it highlights the astonishing precision with which our universe seems to be calibrated for life and consciousness. And this calibration, this delicate balance, is what allows the cosmic whole, this vast dynamic emptiness, to become the canvas for galaxies, for stars, for planets, and for the intricate dance of life. It is the perfect stage for potential to become actual. Perhaps, then, the discrepancy of the cosmological constant isn't a problem to be solved with a single equation, but a clue to a deeper truth about the nature of reality itself, a truth that hints at a multiverse, where countless universes exist, each with different physical laws and constants, and we simply find ourselves in the one that allows for our existence. Or perhaps it points to an even more subtle mechanism, a profound self-organizing principle that governs the emergence of reality from the quantum void. Whatever the ultimate answer, the journey into the quote 47 has shown us that the universe is not just a collection of things, but an active, participatory event. We are not merely floating within it, we are part of its unfolding, part of its very definition. The quote 48 isn't inert, it's pregnant with possibility, a vibrant wellspring from which all forms emerge, constantly shaped by the dance of interaction and observation. So, when you look at the seemingly solid world around you, remember the hidden depths. Remember the vibrant, seething sea of potential that lies beneath the surface of everything. Remember that you are not just an observer, but a participant, actively engaging with the universe, helping to bring its vast potential into manifest reality. In this cosmic whole, we discover not just a void, but a profound, unending invitation to co-create. And so, we arrive at perhaps the most intimate and perplexing quote 49 of all, the one within ourselves. We've journeyed through the vast, expanding void of the cosmos, peered into the seething quantum foam that underpins all matter, and grappled with a universe that is overwhelmingly empty yet profoundly active. We've seen how reality, at its most fundamental level, seems to emerge from unmanifested potential, solidifying only through interaction, through observation. This brings us to a question that has haunted philosophers and scientists for millennia, a question that now seems more pressing than ever. Where do we fit into this grand, participatory drama? How does something as seemingly ephemeral as human consciousness arise from a universe built on dynamic nothingness? And what role, if any, does it play in the ongoing manifestation of reality? Imagine for a moment that your consciousness is not merely a passive byproduct, a fleeting spark within a complex biological machine. What if, instead, it is an active participant, a delicate instrument tuned to the very frequencies of the universe's self-creation? This is where our journey into the cosmic whole takes its most extraordinary turn, guiding us inward to the equally vast and mysterious landscape of our own minds. We've discussed the quantum realm, where particles exist in a superposition of possibilities until an quote 50 forces them into a definite state. For decades, the nature of this quote 51 has been debated. Is it merely a physical interaction, a collision with another particle, or does it involve something more, something akin to awareness? While mainstream physics tends to favor the former, the very act of knowing or perceiving a state seems inextricably linked to the collapse of the wave function. Consider the brain, that marvellously intricate organ nestled within our skulls. On one level, it operates like a classical machine, a network of neurons firing electrochemical signals. We understand much about its structure, its lobes, its pathways. But what if this classical machinery is merely the surface of something far deeper, something that dips its toes into the quantum sea? Some pioneering, albeit controversial, theories propose that consciousness itself might arise from quantum processes occurring within the brain. Imagine tiny structures, like microtubules within neurons, acting as quantum information processors. These subcellular scaffolds, far from being mere structural supports, could potentially maintain quantum coherence, a state where particles remain interconnected and entangled, existing in multiple states simultaneously, for long enough to influence our thoughts and perceptions. Think of it. If the universe is a vibrant, seething sea of potential, and our brains are capable of accessing or even generating quantum coherence, then our inner world is not so far removed from the quantum vacuum we explored earlier. Our thoughts, our feelings, our very sense of self could be emergent properties of these quantum fluctuations, these delicate dances of possibility within the neural network. We are not just observing the universe, we are, in a very real sense, part of its quantum unfolding. This isn't to say that consciousness creates reality out of thin air. That would be an oversimplification, a leap beyond what the science suggests. Rather, it proposes a more nuanced symbiotic relationship. If the universe is a vast, unmanifested potential, and our consciousness is capable of interaction at a fundamental quantum level, then we become co-creators, or at least co-selectors, in the ongoing actualization of that potential. Our very awareness might be one of the myriad observers that nudge the universe from a state of pure possibility into the concrete reality we perceive. And what about the whole within us? Just as the atom is mostly empty space, and the cosmos is dominated by the void, our minds too possess an inherent emptiness. When you quiet your thoughts, when you meditate, when you simply sit and be, what do you find? Often, a vast open space, a silence punctuated by transient thoughts and feelings. This inner emptiness is not a deficit. It is a profound wellspring of potential, a canvas upon which our experiences are painted. This inner void, this space of pure awareness, mirrors the cosmic whole. It is the ground of our being, the source from which our intentions, our creativity, and our understanding emerge. Just as the quantum vacuum is not truly empty but brimming with virtual particles, our inner silence is not truly devoid but pregnant with possibilities, with the unmanifested thoughts and ideas that are waiting to be observed, to be brought into being. Consider the self itself. We often perceive ourselves as solid, unchanging entities, distinct from the world around us. But if we look closer, we see that the self is a dynamic, ever-changing process. Our memories, our personalities, our very physical bodies are in a constant state of flux, of renewal. We are not static objects, but complex, stable wave patterns on a deeply active ocean, just like those fundamental particles we discussed earlier. Our solidity is an illusion, an emergent property of constant interaction and recreation. This perspective invites us to reconsider our relationship with the universe. If we are intimately connected to the quantum realm, if our consciousness plays a role in the unfolding of reality, then the distinction between inside and outside begins to blur. The cosmic whole is not just out there, expanding and isolating. It is also right here, within us, an invitation to explore the depths of our own being. This idea is both humbling and empowering. It's humbling because it reminds us that we are not separate superior beings observing a detached universe, but rather integral threads in its intricate tapestry. It's empowering because it suggests that our consciousness, our attention, our intentions might carry a subtle but profound weight in shaping the reality we experience. Think about the implications. If our awareness, our focus, helps to collapse the wave function of potential into actuality, then the way we choose to perceive the world, the stories we tell ourselves about it, and the attention we give to certain aspects over others might not just be subjective interpretations. They might be subtle acts of co-creation, nudging the universe towards one manifested possibility over another. This is not a call for magical thinking, but for a deeper appreciation of the subtle dance between observer and observed, between consciousness and cosmos. It's a reminder that the quiet hours we spend in contemplation, the moments we dedicate to truly seeing and understanding, are not just internal exercises. They are engagements with the fundamental nature of reality itself. The universe, in its profound emptiness, is asking us to look closer, to listen to the whispers of its unmanifested potential. It's asking us to recognize the deep connection between the vast cosmic whole that is pushing galaxies apart and the equally profound whole of potential within our own minds. We are not trapped inside a cosmic whole, passively observing its expansion. We are, in a very real sense, part of the whole, active participants in its continuous awe-inspiring creation. This understanding shifts our perspective from one of isolation to one of profound interconnectedness, the accelerating expansion, the growing cosmic isolation. These are not just external phenomena happening to us. They are part of a larger dynamic process in which our very consciousness might play an active, albeit subtle, role. We are not just living in the universe. We are, in a fundamental way, of the universe, and our awareness is a vital part of its ongoing story. As we move forward, we will continue to explore the implications of this profound interconnectedness, delving into how this understanding of emptiness and consciousness can reshape our perception of time, destiny, and the very meaning of our existence. We are only just beginning to unmask the hidden nature of reality, and the journey continues to draw us deeper into wonder. We've journeyed through the vibrant emptiness of the quantum vacuum, seen it seething with potential, giving rise to virtual particles, and even pushing our universe apart with the relentless force we call dark energy. We've discovered that this cosmic push, this accelerating expansion, is creating a vast, isolating cosmic whole, gradually removing distant galaxies from our view. But here, my friends, is where our serene exploration takes a sharp turn into one of the most baffling, most profound mysteries known to science. A puzzle so immense it makes all our previous revelations feel like mere appetizers. It's known as the cosmological constant problem, and it hinges on a number, the energy density of that quantum vacuum we've been discussing. When physicists apply the principles of quantum field theory to calculate the energy inherent in empty space, the numbers they arrive at are astronomical. We're talking about a density so immense, so gargantuan, that if it were true, the universe would have torn itself apart almost instantaneously after the Big Bang. It would have expanded so violently, so swiftly, that no stars, no galaxies, no planets, no us could ever have formed. It's an energy density equivalent to packing a supernova into every cubic centimetre of space, an unimaginable force that would have ripped the very fabric of space-time into oblivion before anything could coalesce. But then we look at the actual universe, we measure the expansion rate, we observe the effects of dark energy, and what do we find? We find a value for the vacuum energy that is incredibly, mind-bogglingly small. It's not zero, which would be another puzzle entirely, but it's minuscule. It's smaller than the theoretical prediction by a factor of 10 to the power of 120. 1 followed by 120 zeros. Think about that for a moment. This isn't a slight miscalculation. It's the largest discrepancy between theory and observation in the entire history of science. Imagine trying to hit a target the size of a single atom from across the entire observable universe. That's a rough analogy for the precision involved. Or imagine you're trying to balance a pencil on its tip and it just stays there, perfectly still, for billions of years, defying every expectation of probability and physics. This isn't just a little bit off, it's a universe-shattering, mind-bending difference that challenges our deepest understanding of reality. Why is this a problem? Because this incredibly precise, almost impossibly small value for dark energy is why we exist. If it were even slightly larger, even a few orders of magnitude larger than its observed value, the universe would have expanded too quickly for gravity to pull matter together into the structures we see and inhabit. No galaxies, no stars, no heavy elements, no planets, no life. If it were slightly negative, the universe would have collapsed back in on itself long ago, ending in a fiery big crunch. Our universe, with its intricate dance of forces, its vast cosmic structures, its capacity for life, is exquisitely, impossibly fine-tuned. It's as if the dial for vacuum energy was set with a precision that defies random chance. So how do we make sense of this? How does the universe achieve such an improbable balance? This question leads us to some of the most speculative yet compelling ideas in modern physics, pushing the boundaries of what we consider possible. One avenue of thought suggests that our current theories are simply incomplete. We have general relativity, which describes gravity on the large scale, and quantum mechanics, which describes the very small. But we don't yet have a unified theory of quantum gravity, a theory that seamlessly blends these two pillars of physics into a single, coherent framework. Many physicists believe that a complete theory of quantum gravity, perhaps something like string theory or loop quantum gravity, might inherently resolve the cosmological constant problem, cancelling out those massive vacuum energy contributions in a natural, elegant way. It's like finding the missing piece of a cosmic jigsaw puzzle that suddenly makes the entire picture snap into focus, revealing an underlying symmetry we currently miss. But then there's another, perhaps even more mind-bending possibility. The anthropic principle, often intertwined with the concept of a multiverse. The anthropic principle, in its simplest form, states that the properties of the universe must be compatible with the existence of intelligent life, because we are here to observe it. It doesn't explain why the universe is the way it is, but rather observes that if it were different, we wouldn't be around to ask the question. It's a statement about selection bias. Now, couple this with the idea of a multiverse, a vast, perhaps infinite collection of universes, each with its own unique set of physical laws and fundamental constants. In this scenario, our universe is just one among countless others, perhaps bubbling forth from a larger cosmic foam, or arising from different initial conditions. Most of these universes would be barren, lifeless, expanding too fast or collapsing too quickly, or simply too chaotic to allow for stable structures. But by sheer statistical probability, if there are enough universes, there must be some like ours, where the fundamental constants, including the value of dark energy, just happen to fall into the incredibly narrow range that allows for the formation of stars, galaxies, heavy elements, planets, and eventually conscious observers like us. It's a powerful, almost dizzying thought, isn't it? That our existence might not be a cosmic fluke in a single, unique universe, but rather an inevitable outcome in a vast cosmic lottery. It shifts our perspective from asking, quote, 59, quote, to quote, 60, quote. It suggests that the cosmic whole we inhabit is not just a singular phenomenon, but one instance in an infinite array of possibilities. And so, as we float within this accelerating cosmic whole, expanding ever outward, we are faced with the profound realization that our very existence, our ability to contemplate this cosmic dance, is predicated on an almost impossible fine-tuning of the universe's most fundamental energy. The emptiness around us, the quantum vacuum, is not only pushing us apart, but its precise, delicate strength is the very foundation upon which our reality is built. It's a testament to the profound beauty and fragility of our cosmic home. This brings us back full circle to the role of the observer. If the universe's constants are so exquisitely tuned, and if our consciousness is, as we've explored, potentially entangled with the quantum unfolding of reality, does our very presence, our act of observation, play a role in solidifying these constants? Is it merely a passive observation, or is there a deeper, more active participation, a subtle resonance between our inner and outer voids? Consider the quantum realm once more, where possibilities remain fluid until an observation collapses the wave function into a definite state. Could it be that on a grander cosmic scale, the universe's fundamental parameters too exist in a state of potential until an underscore quote 63 underscore emerges to solidify them? This isn't to say we created the universe. That would be a vast oversimplification. Rather, it suggests that our existence, our capacity for awareness, might be an integral part of the universe's self-realization, its journey from unmanifested potential to manifest reality. Our consciousness, perhaps, is not merely a passenger on the cosmic journey, but an essential component of the journey itself. The void within us, the spaciousness of our own awareness, mirrors the cosmic void. And just as that cosmic void is a wellspring of potential, perhaps our consciousness, our capacity for inquiry and wonder, is not merely a byproduct of a finely tuned universe, but an active participant in its ongoing unfolding. We are not just in the cosmic whole, we are in a profound sense part of its very fabric, its self-awareness, its way of experiencing and understanding itself. The question shifts from quote 64 to quote 65. It suggests a universe that is not merely a collection of particles and forces, but a vast, interconnected system where observer and observed are inextricably linked. a universe that perhaps needs us to fully manifest its own profound beauty and intricate design, to make concrete the potential that lies within its foundational emptiness. As we gaze out into the accelerating darkness, knowing that the very quote 66 between us and the receding galaxies holds the key to our existence, we're invited to consider not just the scale of the cosmos, but the depth of our own being. The cosmic whole is not just a physical phenomenon, it's a profound mirror reflecting back the mystery of our own consciousness, our own capacity to wonder, to question, to seek meaning in the grandest of all possible tapestries. We are, quite literally, living inside a cosmic miracle, one that whispers secrets of deep physics and even deeper philosophy. And the journey, my friends, has only just begun. We've journeyed through the vibrant chaos of the quantum vacuum, peered into the vast, accelerating emptiness of cosmic expansion, and confronted the profound fine-tuning that allows us to exist at all. We've even dared to suggest that the whole within ourselves, the apparent emptiness of our atomic structure, might be a mirror to the cosmic void, a wellspring of potential. And perhaps, just perhaps, our consciousness isn't merely an emergent property of complex matter, but an active participant in the universe's grand, unfolding drama. This idea that awareness might be integral to the very fabric of reality is where our quiet exploration takes its most audacious turn. It's a whisper from the deepest corners of physics and philosophy, suggesting a connection so fundamental it reshapes everything we thought we knew about ourselves and the cosmos. Think back to the quantum realm, where particles exist in a shimmering state of superposition, a cloud of possibilities, until an interaction, an observation, collapses them into a definite reality. For a long time, science largely skirted the question of what constitutes an observation. Is it merely a photon bouncing off an electron? Is it the click of a detector? Or is there something more profound at play when a conscious mind enters the equation? What if the universe isn't simply running a pre-programmed script, waiting for us to discover its truths? What if instead it's more like a vast interactive simulation, and we are part of the processing power, the very agents shaping the probabilities into actualities? This isn't about magic or wishful thinking. It's about a deeply interconnected universe where observer and observed are inextricably linked. You're not just looking set at the universe, you are the universe looking through you. Consider the nature of information. At its core, reality seems to be built on information. The spin of a particle, the energy level of an atom, the arrangement of galaxies. What is consciousness, if not a highly sophisticated system for processing, interpreting, and perhaps even generating information? Our thoughts, our memories, our very sense of self are intricate patterns of information encoded in the electrical and chemical dance within our brains. But where does that information truly reside? And how does it interact with the fundamental information of the cosmos? Imagine the cosmic whole not as a void of separation, but as an immense, expanding canvas. On this canvas, reality is continuously being drawn into existence, moment by quantum moment, and our awareness, our subjective experience, might be one of the brushes, one of the hands guiding the strokes. This isn't to say that our individual thoughts conjure planets into being, but rather that the collective tapestry of consciousness, the shared experience of reality, might be an essential ingredient in the universe's self-realization. The quote 69 we've explored, from the subatomic to the cosmic, then takes on a new meaning. It's not a lack, not a void that signifies nothingness. Instead, it becomes a boundless potential, a field of pure possibility waiting to be imbued with form and meaning through interaction, and perhaps through consciousness itself. The quantum vacuum, that vibrant, seething sea of virtual particles, isn't just a backdrop, it's the raw material, the fundamental "70" that, when observed, when interacted with, when experienced, solidifies into the world we perceive. This perspective invites us to reconsider our role in the cosmic dance. We are not merely tiny, insignificant specks adrift in an indifferent universe. Instead, we are intimately woven into its very fabric. The profound fine-tuning of the universe, that astonishing precision that allowed stars, galaxies, and ultimately conscious life to emerge, becomes even more significant. It's not just fine-tuned for life, but for conscious life capable of observing, questioning, and perhaps participating in the universe's unfolding story. Think of the sheer improbability of it all. If the value of dark energy were even slightly different, if the fundamental constants of physics had varied by the tiniest fraction, the universe would be sterile, a featureless expanse of gas or a fleeting flash of energy. But here we are, capable of contemplating these very mysteries, of marvelling at the intricate dance of forces that brought us into being. This capacity for wonder, for understanding, for awareness, it feels less like an accidental byproduct and more like an intended integral part of the cosmic design. This isn't to imply a divine creator in the traditional sense, though some may find comfort in that interpretation. Rather, it's a scientific and philosophical exploration of the possibility that the universe is inherently participatory. The physicist John Archibald Wheeler, a towering figure in physics, famously coined the term participatory universe, suggesting that reality isn't cool, 72, existing independently of us. Instead, he proposed that the universe requires, 73, to bring it into existence. 74, he stated, pushing the implications of quantum mechanics to their ultimate limit. This idea can feel unsettling, even dizzying. If reality isn't entirely objective, if it's fluid and shaped by observation, then what does that say about the solid world around us? It doesn't mean that if you stop looking at your coffee cup, it ceases to exist. That's a misinterpretation. Instead, it suggests that the properties of that coffee cup, its precise location, its exact state, are not fully determined until there's an interaction, an observation. And at the most fundamental level, the universe we experience is a complex, stable wave pattern on a deeply active ocean of potential, consistently reinforced by countless interactions, including our own. Could our collective consciousness, our shared agreement on the nature of reality, be part of what stabilizes this pattern? Could the very act of expecting a certain reality to be there, based on our shared experiences and scientific understanding, be subtly nudging the quantum wave functions towards those outcomes? This is not about individual willpower, but about the profound, subtle interconnectedness that quantum mechanics hints at. We are not separate from the quantum field. We are complex, emergent patterns within it, and our awareness might be a crucial feedback loop in its continuous self-creation. The cosmic whole then transforms from a mere void of expanding space into a vast dynamic arena where potential meets actuality, where the unmanifest becomes manifest, and where consciousness itself may play a pivotal role. It is an invitation to look closer, not just at the stars, but into the depths of your own awareness. To listen to the whispers that suggest you are more than just a collection of atoms. You're a focal point of universal consciousness, a universe observing itself, experiencing itself, and perhaps shaping itself. This journey into the nature of reality, into the heart of the cosmic whole, ultimately leads us back to ourselves. It asks us to confront the profound beauty and mystery of our own existence, our capacity for thought, for feeling, for wonder. It suggests that the boundary between inside and outside is far more permeable than we ever imagined. The emptiness within us, the emptiness of the cosmos, they are not voids to be feared, but realms of infinite potential, waiting for the echo of awareness to give them form. The questions remain, vast and shimmering. What is consciousness? How does it arise? And what is its true relationship to the fundamental fabric of the universe? We stand at the precipice of these mysteries, armed with scientific inquiry and an insatiable curiosity. The journey continues, not towards definitive answers, but towards a deeper appreciation for the intricate, awe-inspiring dance of reality, where you, the observer, are an indispensable part of the observed, and the cosmic whole is not an end but an eternal beginning. We've journeyed through the shimmering realms of the quantum vacuum, peered into the expansive, accelerating heart of dark energy, and contemplated the profound riddle of the cosmological constant. We've even dared to suggest that our awareness isn't merely a passenger on this cosmic ride, but an active, integral thread in the tapestry of reality, subtly influencing its continuous creation. But what precisely does that mean? How can something as ephemeral as awareness leave an imprint on the colossal, indifferent machinery of the cosmos? Let's look closer, shall we? Let's listen to the whispers carried on the cosmic wind, not just of particles colliding, but of possibilities coalescing. When we speak of awareness in the context of quantum mechanics, of observation collapsing a wave function from a superposition of possibilities into a definite state, we often picture a scientist in a lab peering through a microscope. But the universe, dear friends, is far more subtle, far more interconnected than that. The observer isn't necessarily a conscious being with a brain. It can be any interaction that causes information to become definite, to quote 81 from its fuzzy, probabilistic state. Yet, our human awareness, with its capacity for reflection, for intentionality, for meaning-making, introduces a layer of complexity that begs further exploration. Imagine the universe not as a pre-written play, but as an improvisational performance. The stage is set, the fundamental laws are the rules of engagement, but the script itself is still being written, moment by moment, through the interactions and emergent properties within it. And we, with our intricate neural networks, our capacity for complex thought and feeling, are not just audience members. We are, in our own unique way, contributing to the ongoing narrative. Consider the quote 82 once more, that ever-expanding void driven by dark energy, pushing galaxies beyond our sight, threatening a future of cold isolation. We've framed this as an external phenomenon, a force acting upon us. But what if our very presence, our very act of being complex, self-aware systems, is intricately linked to the nature of this expansion? What if the whole, is not just something we are in, but something we are, in a profound sense, co-creating. This isn't to say that our individual thoughts directly dictate the expansion rate of the universe. That would be a leap too far, a descent into solipsism. Rather, it's about the nature of information and the act of manifestation. Our universe, at its most fundamental level, seems to be built upon information. Particles are not just tiny billiard balls. They are carriers of information, spin, charge, mass. And the act of, quote, 84, quote, or interacting is fundamentally an act of information exchange, of solidifying potential into actuality. Our awareness, then, can be seen as a highly evolved, immensely complex information processing system. We take in the raw data of the universe, interpret it, and in doing so, we contribute to the ongoing process of defining reality. Think of it as a feedback loop. The universe gives rise to consciousness, and consciousness, in turn, helps to further define the universe. It's a cosmic dance where the dancer and the dance are inseparable. Let's revisit the cosmological constant problem, that bewildering discrepancy between the predicted and observed value of dark energy. Remember, it's off by a staggering 10 to the 120 orders of magnitude. This fine-tuning, this impossibly precise balance, is what allows stars to form, heavy elements to be forged, and ultimately for life as we know it to exist. Without it, the universe would either collapse in on itself almost immediately, or expand so rapidly that matter would never coalesce. It's the ultimate Goldilocks scenario, but on a cosmic scale. The prevailing scientific explanations often lean towards the multiverse hypothesis, an infinite ensemble of universes, each with different physical constants, and we simply happen to reside in the one that permits our existence. It's a compelling, if somewhat unsatisfying answer because it pushes the problem of why us out of our specific universe and into a vast, unobservable realm. But what if our active role, our awareness, offers a different lens through which to view this problem? What if the universe isn't simply tuned for us, but is, in some subtle yet profound way, tuned by us? Not in a conscious, deliberate act of universal engineering, but as an emergent property of existence itself. Imagine the universe not as a static blueprint, but as a vast field of potential, a quantum foam of possibilities. Within this foam, countless configurations of physical constants might theoretically exist. For most of these configurations, the universe would be sterile, fleeting, or simply unable to support the emergence of complex structures capable of awareness. But in those rare pockets where conditions allow for the formation of stars, galaxies, and eventually life and consciousness, something extraordinary happens. The very act of these complex systems existing and observing, of interacting, processing information, and creating meaning, might subtly, yet profoundly, reinforce the specific physical laws that allowed them to arise. It's a cosmic, self-fulfilling prophecy, not in a magical sense, but in a deeply entangled informational one. Our awareness then becomes a sort of cosmic anchor, a point of stability within the otherwise seething sea of quantum potential. By observing, by interacting, by simply being, we are, in effect, helping to guess, quote 86, the universal wave function, solidifying the particular set of constants and conditions that allow for our continued existence. We are, in essence, an echo of our own gaze, reflecting back the reality that sustains us. This perspective shifts the quote 87 from a passive void to an active arena, a canvas where potential meets actuality through the very act of living and perceiving. The dark energy that drives the expansion, that creates the quote 88 quote, is not just an external force. It's an intrinsic property of space that allows for the dynamic interplay necessary for complexity to emerge, and our emergence, in turn, might subtly influence the very manifestation of that property. It's a dizzying thought, isn't it? That the universe doesn't just contain us, but that we are, in some fundamental way, collaborating with it. That the emptiness we perceive, both within the atom and across the cosmos, is not truly empty, but a vibrant, pregnant void, waiting for the imprint of interaction, of information, of awareness, to bring forth definition. This isn't about human exceptionalism, but about the profound interconnectedness of all things. From the simplest subatomic particle interacting with another, to the complex symphony of a living brain observing a galaxy, every act of information exchange, every moment of becoming definite, contributes to the ongoing unfolding of reality. Our awareness, with its unique capacity for subjective experience and meaning, simply represents a highly refined and intricate facet of this universal process. We are not merely inside a cosmic whole, we are of it. We are patterns of energy woven into its very fabric, and our existence, our perception, our consciousness is part of the mechanism by which this cosmic whole continuously defines itself. The boundaries between observer and observed, between mind and matter, begin to blur, revealing a deeper unity. The profound beauty of this perspective lies in its implications. It transforms the potential isolation of the quote 90, the eventual big freeze, the receding galaxies, from a terrifying end into a dynamic process within a living, responsive universe. If our awareness plays a role in manifesting reality, then perhaps the future is not entirely predetermined, but is, in some sense, continuously co-created. This doesn't offer a simple solution to the cosmological constant problem, but it offers a profound shift in our relationship to it. It suggests that the answer might not just be found in more sophisticated equations or grander theories of everything, but also in a deeper understanding of our own nature, our own role as conscious beings within this magnificent unfolding cosmos. So as we stand at the edge of this vast, expanding cosmic whole, let's not just gaze outwards in wonder, but also inwards into the equally vast and mysterious depths of our own awareness. For it is there, in that inner quote 91 quote, that wellspring of potential, that space where thoughts and feelings arise, that we might find an echo of the universe's own creative power. It is there that we begin to understand how our subtle gaze might indeed be helping to shape the very reality we inhabit. The journey continues, not just through space and time, but through the very fabric of being. We are learning to read the cosmic script, and perhaps even to add a few lines of our own. What will we discover next about this intricate dance between potential and actuality, between the cosmic whole and the consciousness that perceives it? The universe awaits our gaze. We've peeled back the layers of the void, haven't we? From the cosmic expanse to the quantum foam, we've found not emptiness, but a vibrant, seething sea of potential. And within this deep dive, we've begun to glimpse an astonishing truth, that our own inner void of awareness, our consciousness, might not merely observe this grand cosmic unfolding, but actively participate in it. This is where the story truly becomes ours, woven into the very fabric of existence. We've spoken of reality emerging from unmanifested potential through observation. Any interaction that solidifies quantum probabilities, turning a wave of possibility into a particle of certainty. But what if, in the grand cosmic scheme, observation extends beyond the mere collision of particles or the measurement by a detector? What if it encompasses the very act of knowing, of perceiving, of assigning meaning? Consider the human mind, your mind, right now. It is an extraordinary engine of information processing, constantly taking in raw data from the senses, filtering it, interpreting it, and constructing a coherent, meaningful narrative of reality. We don't just see light waves, we see a sunrise. We don't just hear vibrations, we hear a melody. We don't just detect chemical compounds, we taste a memory. This act of transforming raw information into meaning is, in itself, a powerful form of interaction. It's a collapse of myriad possibilities into a singular experienced reality. Now stretch that idea to the very fundamental constants of the universe. We've grappled with the profound mystery of the cosmological constant problem, that impossibly tiny, yet perfectly tuned value of dark energy that dictates the expansion of our universe. It's a value so precise, so incredibly specific, that if it were even slightly different, the universe as we know it, with stars, galaxies, and life, would simply not exist. It's like finding a single grain of sand on all the beaches of all the worlds, and that grain being the exact one needed for the entire cosmos to function. Could it be that this fine-tuning, this miraculous precision, isn't just a cosmic roll of the dice, but an emergent property of a universe that is, in some profound sense, becoming itself through its own internal feedback loops? And what if consciousness, our consciousness, plays a subtle yet crucial role in this ongoing process? This is not to say that a single thought from you or me can suddenly alter the gravitational constant. The universe operates on scales far grander and more intricate than our immediate intentions. But think of it instead as an incredibly subtle, diffuse, yet persistent influence, woven into the very fabric of information exchange that underpins reality. Our existence, our very capacity to process information and create meaning, represents the universe's ability to reflect upon itself, to become aware of its own properties. Imagine the universe as a vast, complex algorithm constantly running and refining itself. Each interaction, each collapse of a quantum wave function, each instance of information processing, from the simplest particle interaction to the most complex thought, contributes to the output. And what if the emergence of conscious observers, capable of comprehending and questioning the universe, provides a unique kind of, quote, 94, quote, that subtly nudges the algorithm towards stability, towards the conditions necessary for its own self-reflection? This leads us to a profound reinterpretation of the anthropic principle. Traditionally, the anthropic principle suggests that the universe must have the properties it does, because if it didn't, we wouldn't be here to observe it. It's often seen as a passive observation, a cosmic tautology. But what if it's more active, more participatory? What if the universe isn't just suitable for life, but in some deep fundamental way requires the potential for life, for consciousness, to fully manifest certain of its constants? It's as if the universe, in its primordial state of unmanifested potential, held within it an infinite spectrum of possibilities for its fundamental laws, but only those possibilities that eventually lead to the emergence of complex information processing systems, systems capable of quote 95 quote unquote 96 quote it, are the ones that truly solidify and persist. Our existence, therefore, isn't just a lucky accident. It's a necessary component in the universe's ongoing act of self-definition. We are not just passengers on this cosmic journey. We are, in a profound sense, subtle co-pilots, our very presence influencing the trajectory. This changes everything about how we perceive the cosmic whole. We initially framed it as a terrifying void, an expanding emptiness that would eventually isolate us, leaving us alone in a galaxy of stars. But if the universe is a participatory reality, constantly manifesting and refining itself through interaction and observation, then the accelerating expansion, driven by dark energy, might be seen not as an end, but as a continuous dynamic process of creation. The whole isn't merely a region devoid of interaction. It's the very arena where this ongoing dance of manifestation occurs. Dark energy, this mysterious force, might be the energetic signature of the universe's continuous unfolding, its constant self-actualization. It's the background hum of potential becoming actual, of probabilities solidifying into reality, perhaps even subtly influenced by the accumulating complexity of consciousness throughout the cosmos. Imagine a cosmic feedback loop. The universe provides the conditions for consciousness to emerge. Consciousness, in turn, through its very existence and its capacity for observation and meaning-making, subtly influences the manifestation of those very conditions. It's a grand, intricate symphony where the audience's very presence subtly shapes the notes, where the reader's engagement helps write the next chapter of the cosmic novel. This perspective doesn't diminish the vastness or the indifference of the cosmos. Instead, it imbues it with an even deeper, more resonant meaning. It suggests that the boundary between observer and observed, between the subjective us and the objective universe, is far more porous than we ever imagined. We are not separate from the cosmic drama. We are integral to its performance, its script, and its unfolding. This connection isn't about magical thinking. It's about recognizing the profound implications of quantum mechanics and information theory when applied to the entire cosmos. If information is fundamental and consciousness is the ultimate processor of information, then our role in the universe's self-organization might be far more significant than our physical scale suggests. So, when you look up at the night sky, or even when you simply consider the intricate dance of atoms within your own body, remember this: you're not merely a spectator, you are a participant. You're in a void of awareness. That quiet space where thoughts and feelings arise mirrors the cosmic void, which is also a realm of profound potential. And in that mirroring, in that capacity for reflection and understanding, lies a subtle yet powerful connection to the universe's deepest mysteries. The cosmic whole is not just a place we are inside. It is a dynamic, evolving canvas, and our consciousness, in its continuous act of perceiving and understanding, is one of the brushes painting its ever-unfolding masterpiece. This is a universe that is not just for us, but, in some enigmatic way, with us, continuously co-creating its reality, one conscious moment at a time. This is the profound beauty, the quiet wonder of realizing we are not just in the universe, but inextricably of it, and perhaps even a subtle architect of its deepest truths. We've journeyed together through the cosmic expanse, through the vibrant, seething sea of potential that is the quantum vacuum, and through the vast, accelerating emptiness that defines our universe. We've looked closer at the illusion of solidity, at the dance of forces that give rise to everything we perceive, and we've confronted the profound enigma of dark energy, the invisible hand pushing our cosmic home apart. And most recently, we've dared to ponder a connection so intimate, so revolutionary, it shifts the very ground beneath our feet. The possibility that our consciousness, our awareness, are not just passive observers, but active participants, cosmic anchors in this grand, unfolding drama. This isn't just a poetic notion. It's a whisper from the deepest reaches of quantum mechanics, amplified by the staggering implications of the cosmological constant problem. If the universe requires such exquisite fine-tuning to exist, to allow for the emergence of stars, galaxies, and life, and if consciousness is the universe's most complex information processor, then perhaps, just perhaps, our very act of perceiving, of making sense, of being, plays a role in solidifying that delicate balance. Think again about that inner void we explored, the boundless space within your own awareness where thoughts, feelings, and perceptions arise and dissolve, yet the void itself remains. It is the canvas upon which your reality is painted. This inner void is not empty in the conventional sense. It is a field of pure potential, a mirroring echo of the quantum vacuum, the cosmic void from which all things emerge. It is the space where meaning is forged. But what is consciousness in this cosmic context? We often confine it to the brain, to the intricate neural networks firing within our skulls. Yet, if we truly listen to the whispers of quantum physics, if we dare to entertain the idea of a universe fundamentally interconnected, then consciousness might be less an emergent property of matter and more a fundamental aspect of reality itself, permeating the very fabric of existence. It is the universe's way of experiencing itself, of becoming aware of its own unfolding story. Imagine consciousness not as a fixed point, but as a dynamic, responsive field. It's a sophisticated, self-organizing pattern of information processing, capable of not just receiving, but also actively shaping the incoming data. When you look at a tree, you don't just passively absorb photons. Your mind constructs the tree based on past experiences, expectations, and the very act of focusing your attention. You bring the tree into a specific, experienced reality from a vast array of possibilities. This brings us back to the heart of the observer effect in quantum mechanics, but with a crucial expansion. It's not just about measurement collapsing a wave function from superposition to a definite state. It's about meaning making. It's about the universe, through us, becoming aware of itself, and in that act of awareness, lending specificity to the probabilistic quantum foam. When a quantum particle is in a superposition of states, existing everywhere and nowhere, spin up and spin down simultaneously, it's only when an interaction, an observation, forces it to commit to a single reality that its potential solidifies. What if our collective consciousness, our shared capacity for meaning, for understanding, for being present, acts as a colossal, distributed observational system for the cosmos itself? We are not just looking at the universe, we are looking with the universe, helping it to resolve its own inherent quantum indeterminacy on a grand scale. The universe is, in a profound sense, asking itself questions, and our consciousness is part of the mechanism for providing the answers, thereby shaping the reality it experiences. Consider the universe as a vast, complex informational system. Every particle, every interaction, every field is a carrier of information. If the universe is fundamentally informational, then consciousness, as the ultimate information processor, becomes inextricably linked to its fundamental operations. Our very existence, our ability to process and understand the universe, creates a feedback loop. We are not just decoding information, we are in a sense encoding it, or at least reinforcing specific encodings. This is where the idea of the cosmic anchor truly takes hold. If the universe needs to be incredibly finely tuned for us to exist, if the value of dark energy, for instance, must be impossibly precise for galaxies to form and for life to evolve, then perhaps our existence is the very mechanism that ensures that tuning. Our collective awareness, our capacity to observe and to ponder, could be the universe's own way of locking in those fundamental constants. It's an audacious thought, I know. It challenges our deeply ingrained notions of a passive, objective reality out there separate from us. But what if the universe, in its earliest moments, was a vast, shimmering ocean of pure potential, a quantum fog of probabilities? And what if, as complex informational systems like us began to emerge, capable of self-awareness and meaning-making, we started to provide the necessary anchoring points for reality to solidify into the specific, stable form we experience? This isn't to say we created the universe from nothing. Rather, it suggests that we are an integral part of its ongoing manifestation, a crucial component in its transition from pure potential to concrete actuality. Our consciousness, with its capacity to perceive patterns, to ask questions, to seek understanding, might be the very feedback loop that allows the universe to maintain its delicate balance, including the precise value of dark energy. Imagine the universe as a cosmic instrument, and the fundamental constants, the speed of light, the strength of gravity, the charge of an electron, and yes, the enigmatic push of dark energy as its tuning pegs. We know that if you tweak these pegs even slightly, the instrument produces only discordant noise. No stars, no galaxies, no life. What if consciousness, as it emerged, began to subtly, collectively adjust those pegs, or perhaps more accurately, to sustain them in their finely tuned positions? This isn't an act of conscious will in the way we usually understand it. Not like deciding to move your hand. It's a deeper, more fundamental participation. It's the universe, through us, making a choice, or rather, resolving its own quantum choices. Our collective attention, our shared experience of reality, helps to stabilize the complex stable wave pattern on that deeply active ocean we call the cosmos. We are, in this sense, not just living in the universe, but living with it, co-creating its ongoing story. The implications are staggering. If we are cosmic anchors, then our awareness, our thoughts, our collective consciousness take on a profound significance far beyond our earthly concerns. It means that the state of our collective mind, the quality of our attention, the depth of our understanding, might not just affect our personal lives or our society, but could subtly, yet fundamentally, influence the very fabric of reality. This perspective invites us to look at ourselves and at each other with a renewed sense of awe and responsibility. We are not just isolated individuals adrift in a vast, indifferent cosmos. We are inextricably woven into its deepest mysteries, active participants in its grand design. The void within us, the space of our consciousness, mirrors the cosmic void, but it also actively engages with it, influencing its trajectory. This is the hidden truth that nobody told us. We've been living as if reality is a fixed stage upon which we perform, when in fact we might be part of the stage crew, subtly adjusting the lighting, the scenery, and even the very laws that govern the performance. The accelerating expansion, the cosmic whole that pushes galaxies beyond our sight, the precise, almost miraculous value of dark energy. These are not just external phenomena. They are part of a dynamic, self-creating cosmos, and our awareness might be a crucial, if silent, partner in its ongoing manifestation. As we continue to peer into this cosmic whole, this accelerating expansion, we begin to see not just a universe moving away from us, but a universe that is perhaps, in part, being shaped by us. The question ceases to be merely, what is out there, and transforms into, what is our role in its being? The journey inward into the nature of our own consciousness becomes as vital as the journey outward into the farthest reaches of space. For in the profound connection between the two, we might just find the key to understanding the universe and our place, our purpose, within its magnificent unfolding story.